EcosimPro and PROOSIS are software tools for simulating and modeling systems. In the next example, we'll model a series circuit made up of a 5-volt sinusoidal power source, a 1000 ohm resistor, and a diode. The diode is modeled in two different ways, with the Shockley model equation and with equations of an ideal diode bisections. Considerations on the ideal model and Shockley equations are indicated here. First, we load the Book Examples toolkit into the workspace. Then we open the file that has the diode equations. A construction parameter is added to the component. It's an integer called type to determine what equations to use for the diode. This parameter can change when an instance of the component is made, but will remain constant during the simulation. The if insert sentence appears in the continuous block. It's used to enter equations depending on a condition. In this case, if the construction parameter is 1, the equations of the ideal model bisections are included. Otherwise, the Shockley method is used. To define the behavior of the ideal diode, the sequential and end sequential block is used. The code inside is run sequentially even though it's inside the continuous block. After that, a component called diode comp is created to compare how the two different diode models behave. Two diode type components are declared, one that uses the ideal diode and the other that uses the Shockley model. The instance of the components that had been created in another new one is done inside the topology section. When we simulate the model, we see the response of the diode comp component over time, the voltages at the ends of the resistor and at the ends of the diode for both components. It also shows the diode's characteristic curves, the current I vis-a-vis the voltage at each end of the diode. In conclusion, this video has shown how to represent the behavior of the example by entering new modeling language concepts, if insert, sequential, as well as by creating a new component with instances from other previously created components.